Lockout tag, Loto, or locking tag is a safety procedure which is used in industry and research settings to ensure that dangerous machines are properly shut off and not able to be started up again prior to the completion of maintenance or servicing work. It requires that hazardous energy sources be isolated and rendered inoperative before work is started on the equipment in question. The isolated power sources are then locked and a tag is placed on the lock identifying the worker who has placed it. The worker then holds the key for the lock, ensuring that only he or she can start the machine. This prevents accidental startup of a machine while it is in a hazardous state or while a worker is in direct contact with it. Lockout tagu is used across industries as a safe method of working on hazardous equipment and is mandated by law in some countries. Procedure. Machinery can contain many hazards to workers. Some of the common hazards are electricity, hydraulic pressure accumulated in a pumper line, pneumatic compressed air, radiation including intense visible or thermal as well as ionizing or particle beams, extremely hot or cold surfaces, gases, including poisonous, suffocating, explosive, a combination of heat and gas in the form of steam, gravity, falls from height, falling parts, or mechanisms that work with or against it, kinetic spring tension, other moving parts, fans, belts, gears, saw blades, presses, etc. Many types of liquids, chemical, water, etc. For example, an industrial device may contain things such as hot fluids, moving presses, blades, impellers, electrical heaters, conveyor belts with pinch points, moving chains, ultraviolet light, etc. Disconnecting and making safe the equipment involves the removal of all energy sources and is known as isolation. The steps necessary to isolate equipment are often documented in an isolation procedure or a lockout tagu procedure. The isolation procedure generally includes the following tasks: announce shut off, identify the energy source, isolate the energy source, lock and tag the energy source, prove that the equipment isolation is effective. The locking and tagging of the isolation point lets others know not to de-isolate the device. To emphasize the last step above in addition to the others. The entire process can be referred to as lock, tag, and try. That is, trying to turn on the isolated equipment to confirm it has been de-energized and cannot operate. The National Electric Code states that a safety service disconnect must be installed within sight of serviceable equipment. The safety disconnect ensures the equipment can be isolated and there is less chance of someone turning the power back on if they can see the work going on. These safety disconnects usually have multiple places for locks so more than one person can work on equipment safely. In industrial processes it can be difficult to establish where the appropriate danger sources might be. For example, a food processing plant may have input and output tanks and high-temperature cleaning systems connected, but not in the same room or area of the factory. It would not be unusual to have to visit several areas of the factory in order to effectively isolate a device for service, e.g., device itself for power, upstream material feeders, downstream feeders and control room. Safety equipment manufacturers provide a range of isolation devices specifically designed to fit various switches, valves and effectors. For example, most circuit breakers have a provision to have a small padlock attached to prevent their activation. For other devices such as ball or gate valves, plastic pieces which either fit against the pipe and prevent movement, or clamshell-style objects, which completely surround the valve and prevent its manipulation are used. A common feature of these devices is their bright color, usually red, to increase visibility and allow workers to readily see if a device is isolated. Also, the devices are usually of such a design and construction to prevent it being removed with any moderate force. That is to say that an isolation device does not have to stand up to a chainsaw. But if an operator forcibly removes it, it will be immediately visible that it has been tampered with. To protect one or more circuit breakers in an electrical panel, a lockout tag device called the panel lockout can be used. It keeps the panel door locked and prevents the panel cover from being removed. The circuit breakers remain in the off position while electrical work is done. Group lockout. When two or more people are working on the same or different parts of a larger overall system, there must be multiple holes to lock the device. To expand the number of available holes, the locked-out device is secured with a folding scissors clamp that has many pairs of padlock holes capable of keeping it closed. Each worker applies their own padlock to the clamp. The locked-out device cannot be activated until all workers have removed their padlocks from the clamp. In the United States, a lock selected by color, shape or size, e.g., red padlock, is used to designate a standard safety device, locking and securing hazardous energy. No two keys or locks should ever be the same. A person's lock and tag must only be removed by the individual who installed the lock and tag, unless removal is accomplished under the direction of the employer. Employer procedures and training for such removal must have been developed, documented and incorporated into the Employer Energy Control Program. Identification. By U.S. Federal Regulation 29, CAFR 1910.147. C. 5. E. C. 1. The tag must have an identification showing the name of the person doing the lock and tag. While this may be true for the United States, it is not mandatory in Europe. The lockout can also be done by a role, such as the shift leader. Using a lockbox, the shift leader is always the last one to remove his lock. He has to verify it is safe to start up equipment. The 5 security steps. According to the European standard N 50110-1, the safety procedure before working on electric equipment comprises the following 5 steps. Disconnect completely. Secure against reconnection. Verify that the installation is dead. Carry out earthing and short-circuiting. And provide protection against adjacent live parts. Site policies regarding lockout tag. Many sites have the officially stated policy that only the person who tagged the device can untag it. This means that if a worker goes home after their shift without removing the tag from a device which is ready to use, then they will have to travel back to the site to untag it. Giving approval for the removal of a tag over the phone is prohibited. While this policy might seem to be encouraging workers to take the risk of not tagging out in the first place, it is usually accompanied by a policy stating that working on a device without tagging it out will result in instant dismissal. Industry safety standard in Canada. All Canadian jurisdictions legally require lockout for certain work. However, the specific activities required for appropriate lockout are usually not specified in law. These specifics are provided through industry standards. The Canadian Standards Association's standard CSA Z 460, based on industry, labor and government consultations, outlines the specific activities of a lockout program and is usually considered the appropriate standard of good practice for lockout. All Canadian health and safety legislation places a general duty on an employer to take all reasonable precautions, and carrying out this standard of good practice is usually considered a mark of due diligence. Industry safety standards in the United States. Lockout Tagu in the U.S. has 5 required components to be fully compliant with OSHA law. The 5 components are: lockout tagu procedures, documentation, lockout tagu training for authorized employees and affected employees, lockout tagu policy, often referred to as a program, lockout tagu devices and locks, lockout tagu auditing, every 12 months. Every procedure must be reviewed as well as a review of authorized employees. In industry, this is an Occupational Safety and Health Administration (OSHA) standard, as well as for electrical NFPA 70E, OSHA's standard on the control of hazardous energy. Lockout tagu, found in 29 CAFR 1910.147, spells out the steps employers must take to prevent accidents associated with hazardous energy. The standard addresses practices and procedures necessary to disable machinery and prevent the release of potentially hazardous energy while maintenance or servicing activities are performed. 2 other OSHA standards also contain energy control provisions. 29 CAFR 1910.269 and 29 CFR 1910.333. In addition, some standards relating to specific types of machinery contain de-energization requirements such as 29 CAFR 1910.179 L2 I.C. requiring the switches to be open and locked in the open position before performing preventive maintenance on overhead and gantry cranes. The provisions of POP 1910.147 apply in conjunction with these machine-specific standards to assure that employees will be adequately protected against hazardous energy compliance. If employees service or maintain machines where the unexpected startup, energization, or the release of stored energy could cause injury, the OSHA standard applies, unless an equivalent level of protection can be proven. Equivalent level of protection may be achieved in some cases through standard operating procedures, SOP, and custom machine guarding solutions that are combined to establish machine control to protect the worker for specific tasks. The standard applies to all sources of energy, including, but not limited to, mechanical, electrical, hydraulic, pneumatic, chemical, and thermal energy. The standard does not cover electrical hazards from work on, near, or with conductors or equipment in electric utilization, premise wiring, installations, which are outlined by 29 CFR Part 1910 Subpart S. The specific lockout and tagu provisions for electrical shock and burn hazards can be found in 29 CFR Part 1910.333. Controlling hazardous energy in installations for the exclusive purpose of power generation, transmission, and distribution, including related equipment for communication or metering, is covered by 29 CAFR 1910.269. The standard also does not cover the agriculture, construction, and maritime industries or oil and gas well drilling and servicing. Other standards concerning the control of hazardous energy, however, apply in many of these industries and situations. Exceptions. The standard does not apply to general industry service and maintenance activities in the following situations: when exposure to hazardous energy is controlled completely by unplugging the equipment from an electric outlet, and where the employee doing the service or maintenance has exclusive control of the plug. This applies only if electricity is the only form of hazardous energy to which employees may be exposed. This exception encompasses many portable hand tools and some cord and plug connected machinery and equipment. An employee performs hot tap operations on pressurized pipelines that distribute gas, steam, water, or petroleum products, for which the employer shows the following. Continuity of service is essential. Shutdown of the system is impractical. And the employee follows documented procedures and uses special equipment that provides proven, effective employee protection. The employee is performing minor tool changes or other minor servicing activities that are routine, repetitive, and integral to production, and that occur during normal production operations. In these cases, employees must have effective, alternative protection.